Welcome back to my channel. In this video we will be setting up a LAN-to-LAN policy-based VPN tunnel between a Check Point security gateway and a Cisco router. This type of VPN ensures secure communication between two LAN networks using predefined security policies to control encrypted traffic. We will configure phase 1, which is ACLs in Cisco router, and phase 2, the IPsec. Set up encryption and authentication parameters, define access control rules for traffic encryption, and ensure the VPN tunnel is properly established. This setup is ideal for connecting remote branch offices securely over the internet. By the end of this tutorial, you will have a fully functional LAN-to-LAN policy-based VPN between Check Point and Cisco, ensuring secure and seamless connectivity between the two networks. So let's get started. So here I have built this topology here. Here we have our Check Point gateway, and here we have a Cisco router. So the plan here is that this network here, or this client, or this server, you can name it what you need, should reach this client or server here, and vice versa. So both should reach each other through a VPN tunnel. So first let's configure this router here. So this is my router. So let's go in there and go to the configuration terminal. So the first command is we need to create a crypto ISAKMP policy. So let's get that command here. So crypto ISAKMP policy 1. In this policy we will define what is the encryption algorithm, what is the data integrity algorithm, and which Diffie-Hellman group should be used. So we can take encryption here and we can check. So let's take ACE here, and we take the most secure 256. The second thing is the integrity, and here it's called hash, and we can check what we have. So we can take show 256, and then we need to say that you need to use the pre-shared password. So authentication is pre-share, and we can take exit here. And before exit we need to define the Diffie-Hellman group 14, something like that, and exit. The next step is to define our pre-shared password. So crypto, this one, let's take this one. So crypto ISAKMP key, the password is VPN test, and address, and this is our gateway. So if we look here, we can see that, oh yeah, this is the 65, so let's change that to 65. So this is the IP address of the peer, the gateway. So let's take that, and then we need to define the phase 2, so the IPsec. So now we need to define the phase 2 here, and we use crypto, this command, crypto IPsec, this transform set. This is the command that we use, and here we need to call it something. So let's call it tset, and now we need to choose the method that we are going to use. So here let's take ESP ACE, and let's take 256, and then we can take ESP show 256 and HMAC. So now we have defined the encryption algorithm and the data integrity algorithm, which is ACE256 and SHA-256. And now we need to define an access list, which is used to define the specific traffic that should be encrypted by the IPsec VPN tunnel. The access list acts as a filter to match the traffic that will be sent through the tunnel. Only traffic that meets the criteria specified in the access list will be encrypted. Other traffic will be sent without encryption. So, in our example here, we will define that traffic from this subnet, the 1066, will be permitted to be sent to this subnet, 172.25.10. So let's go out of this access list. Let's grab it from, I've already done that. So the 101 is the number of the access list or extended access list. We are permitting this subnet to reach that subnet, and we click enter here. Next step is to create a crypto map. This command. So a crypto map in a Cisco router is a configuration that defines how IPsec VPN traffic should be handled. It binds together the necessary parameters for an IPsec VPN tunnel, including peer IP addresses, encryption settings, authentication methods, and access control lists that define interesting traffic. A crypto map is essentially the interface that tells the router how to handle IPsec VPN traffic and which traffic to secure. So let's open that. And here we need to define our peer. So set peer, and our peer is 1065. And then we need to define the transform set. So set transform set, and our transform set is this set here, tset, and we need to match our access list. So match address 101, like this, and exit. And the last step is to apply this crypto map on the external interface. So we need to apply it on this interface, Giga1, external interface of the router. So let's go to that interface, Giga1, crypto map, see, crypto map test, exit here. So now we are done here. Let's do save this configuration. Now it's time to go to our checkpoint and create a new. So this is here. We will use this on this gateway. Let's first enable IPsec VPN. Okay, and now we can create a new community here. Star community. Let's call this Cisco VPN, for example. Legacy. Let's define, or first, okay, let's add the gateway. The gateway is this one, and here I have defined the Cisco router at this one. So we need now to add the VPN domain. So in this case, our domain will be this subnet for the gateway, and for the router will be this subnet here. So let's add these. So override, and let's take 172.25. So the gateway's VPN net. And here we define the same for the router, 1066 and this is the Cisco VPN net. Okay, in the encryption, here it should be the same, and here, because in Cisco we are using ISAKMP version 1, so we need to be able to use that, so we can choose prefer ISAKMP version 2 but support for ISAKMP version 1. I will do another video on how to configure a Cisco router to create a VPN with Check Point using the ISAKMP version 2. So we chose, in Cisco we chose ACE256, SHA-256, let's choose that, and group 14. Same as there, we need to use ACE256 and SHA-256. Let's look here, advanced, we don't need NAT inside the tunnel. VPN routing, okay, that look good. So let's click OK there. Let's create a policy now. So above this, so the source be able to send and receive, so we need both here. So we put this and we add the other, the Cisco or 1066, this one, so that we can send and receive the same rule. So let's choose our new created Cisco VPN, this one, services any, and accept and log. Let's do drop here and let's install the policy. How many changes? 12. So let's install the policy and then try to ping. So this one, install. So now the installation process is done, but I forgot to add a shared secret here. So let's add that. Let's activate this and VPN test. Click OK, and we need to install the policy again. Let's install the policy again. Okay, so now let's try to run some commands here. So show crypto IPsec SA to see. So we can see here that there's a test. So let's try to ping. So let's go there. Let's run this one and try. Let's show IP. Okay, it's configured correctly. So ping. Let's ping the gateway. For example, 10.1, and we get no ping. So let's go to our logs here and try to find any log. So we are trying to ping 172.25.10. Let's take any IP address there, and we can see that we are. So let's try to ping from this side this time. Open. So show IP. Okay, the IP is correct. So ping 10.662, and now we are getting a ping. So let's check this IP here, and we can see that this is perfect. And in the router here, we can try show crypto IPsec SA, to see that we are sending and receiving packets here. So you can see some packets and some traffic. So what we can do, so show crypto ISAKMP SA. Here we can see that we are status active, and this is the QM idle. So this is the right state, the correct state, and we have some packets, and again we can use this one. Okay, let's ping the device. As you can see, we can reach that also. So let's check the logs again. Okay, on my router, if we try to, for example, ping 8888, okay, this will not be logged on the gateway, because if we look at my show IP route here, we can see that my last result is this one, and this is my home router. So if we want to send all traffic with the gateway, so all traffic is encrypted, so we can remove this. So config terminal, so no IP route and add this interface, this one, as the last result or the default gateway. So let's do that. So IP route, and these zeros means send everything to that IP. So like this 10, and now if we ping 8888, okay, it is not going because we need to allow that. So let's go there and fix our, maybe if we change this to accept, we will have a good example, only to demonstrate that. So install. So the goal here is to send all traffic from the router, if you want, directly to the gateway and then out, but not encrypted, because the 8888 is not included in the VPN domain. So again, if we try here, let's try to only ping. Now it's working. So if we check there our logs again, now we can see, let's do that again. Okay, one more time. Here we can see that our Cisco router, which has this IP address, is a ping Google, and that is accepted, and it's accepted by the rule number 2. So if we need to encrypt this traffic, we need to add any traffic that is needed to be encrypted. You should add it to the VPN domain in the router and in the gateway. In the router, the crypto map, the access list, you need to add it there, so it will be encrypted. So let's go back to our router here and check if we have more crypto IPsec SA. So we can see that we have some packets here. So everything is working. In the next video, I will create a video about ISAKMP version 2, which is a bit complex to configure. but it's the newer version of the ISAKMP protocol. So this video is done here, so thank you for watching and see you in the next video.